Hello party people, welcome to the show. My name's Irrelevant and this is Do All the Things, and today on the show, a bit more epic a presentation, for I am going to clone, or attempt to clone, a Marshall Jubilee 2550 into this old Traynor Voice Master chassis. So as you know, I've been doing a series of old tube amp videos, and you know, I've worked on these amps quite a bit, and I've done clones before. And whereas most people might start with something like a 5E3, I went to the moon, and my first clone was actually a Mesa dual rectifier. Reverse engineered, of course. It was just the red channel, one channel, high gain. Took me about 5 years to get it right because, you know, I didn't know what I was doing back then, but now I can kind of sneeze out a 4.0 circuit if I really wanted to. And in a previous video, I showed you just that, where I had a form of 4+0 high gain circuit in this chassis. But you know, it was a mess circuit. It was pretty awesome, but yeah, it wasn't necessarily voiced right. And you know, I'd have to put more work into it. And I decided I wanted to do something else with this. I wanted to gut it out and do another project. And I kind of was debating what I wanted to do. You know, I was thinking of doing something simple like a Bassman, but then I was talking to a buddy and we were talking about tube amps, and we were discussing the 2550, the Marshall Jubilee. And I got looking at the schematic and looking at the layout, and I'm thinking, you know, I've always been curious about that amp myself. Maybe it's time I give it a try, and this chassis has the perfect provisions for it. On the front, we got more than enough knob positions for everything that we need on that amp, because it's got, you know, like one more knob than normal, so not all chassis would accommodate it. Because of some previous experiments, I already have a relay setup installed in here, so that accommodates that foot switch facility, even though I don't have the right jack for a foot switch right now, so it'll be push button only. And the Voice Master was unique as far as vintage amps goes because it was one of the few that had something resembling an effects loop. So I have that facility too. And then of course, there's more switches and jack positions on the back for me to have my rhythm clip, channel select. The foot switch will go here. Also worth noting is the Voice Master was designed to be a PA head, so it was a little bit overbuilt compared to other amps of the time. And one feature it had was these larger than normal transformers. Similar Traynor amps in this power range would have had smaller transformers because they were designed for guitar amp. They didn't need as much headroom. These transformers are capable of going to full power with this amp without saturation while staying tight. And that's great for modern metal tones. How much the Jubilee was designed like that, I don't know. I don't know much about its transformers. But we got to work with what we got, and this is what we got, and I think it's going to do the job well. Now, of course, one of the hardest things about this and one of the biggest challenges is figuring out how to take that circuit and figuring out how to work around, get it into this particular board. As you can see, this is just a very simple, not even a turret board. These aren't called turrets. They're brass bushings or something, little rivet-like devices. But the circuit just stretches back and forth and back and forth and back and forth. Now, the layout isn't going to be 100% optimal. However, I've built circuits with significantly more gain into this than the Jubilee has, so I know I can make a stable circuit in here. And of course, solving this problem meant drawing a layout, which is what I've done here. This is a weird old PCB design program that I use, and it's not exactly optimal for a tube amp, but it does the job. And basically I drew out the PCB board in here, and then I had to figure out how to get tick, 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 all the components to line up. I cheated a bit and I referenced hugely the Seriatone 2550 layout. Seriatone has a clone of the 2550 and the 255555. You can go ahead and pretty much buy a Jubilee from them, and they also sell them kits. And the documentation that goes with the kit is the layout to show you how to wire it up. So I did reference heavily this particular layout schematic to try to get an idea of how the components are supposed to be laid out, and then I transposed it over to this system. I was fortunate and I had just enough room. I kind of knew I would. So as you can see here, I've got the chassis gutted and ready to go, and it's not 100% gutted because I didn't have to. Now, there are some circuits that I left in place. Namely, there's the rectification. Now, the rectification in this amp is slightly different than how Marshall does does it. They use the different kind of full wave rectifier because it has the center tap transformer. This doesn't have the center tap type transformer, so it needs the standard bridge rectifier. There's really no advantage or disadvantage in the power supply circuit. It's going to have the least effect on your tone, assuming certain fundaments still line up. Now, these transformers are going to be slightly lower voltage than what the Jubilee runs at. This isn't the biggest deal in the world because if you know what you're doing, you can easily compensate for that. The power section is not going to be as sensitive to voltage as long as you hit the correct general range. It's pretty much going to function identically. You just, bias and tweak on it a bit different. It's the preamp circuit that's up for philosophical debate because you don't want those voltages to change. Now, if we look at the 2550 schematic, so coming in from the B plus here, it goes there, it goes through the choke, and then there's the filter capacitor. This section here runs the screen grid. Now, we have a 10K drop resistor right here that drops the voltage down to run the preamp correctly. We're going to have to tweak on the value of that to bring the voltages up to where they need. Determined previously in building this amp, a 2.7K was what I was using. That may or may not also fill the bill here. This is what we're going to end up using here, and things should be fine. We can tweak voltages from there if we find they're particularly off. Unfortunately, this schematic doesn't really tell us the voltages of the tubes, or does it? No, I can't really find them. So we might have to do some further research to sort that out. Talking about the power supply in these positions, well, I got a couple 50-50 cans to go in there. That's what Marshall calls for in the schematic. But also further down the line, they also have a 50-50 here for the preamp section. Now, why would Marshall do something like that? It's not because it's the best. Oh, no. You got to remember, this is a corporation here. It's because it's cheaper. A 50 is going to do the job well, but it's grossly overrated for the application. A preamp doesn't need anywhere near that big of capacitors. In the Seratone layout, they went down to a 47 UF. We're actually going to go even lower than that, and well, I have a couple 22 UFs here. Keeping with the spirit of how some corporate might design their schematics, these were the cheapest ones. In fact, these were half the price of even a 16 and definitely a 47. And I know from experience, this should have more than enough power for the preamp, so I'm not too worried about that. While I'm in here, I'm probably going to change out these capacitors for the bias circuit. That's another thing we're leaving in place. Bias circuits don't really have any effect on the tone outside of how you dial them in. They're pretty much all the same. So bam, that stays right there. And in fact, this amp has a different transformer that has a separate power supply for the bias circuit. So we couldn't even wire in the same kind of bias circuit they have here. Also left in place is the phase inverter. Phase inverters are all the same. Pretty much, you look at Fender, Mesa, Marshall, 5150, Crate, they are all pretty much the same. Now, the presence is something else that I left in place because those are also pretty much the same. And in fact, the Seratone is a bit different from the actual Marshall schematic. We just have the 1 UF capacitor on a 5K, but if we look at the Marshall schematic, the presence has a combination of a 1K and a 4.7K, and then a 10 ohm before ground on a 22K pot. This guy has the 4.7, it has the 1U capacitor, it doesn't have that 10 ohm ground shunt, but it has a 10K pot, so it's kind of splitting the difference. We're just gonna leave that in place, save us some time. Again, if we really find the tone screwy, well, we can change it, right? Everything else has pretty much had to be gutted. Now this has 1, 2, 3, 4, 5, 12 AX7 positions. We only need 3. That and that are being omitted. We might be able to use those for mods in the future, whatever. I pretty much have all the potentiometers I need, even though they aren't necessarily the correct taper. Our input gain 1 meg audio. That should be easy. I got all sorts of 1 meg pots. They're so common. The lead master is a 250K linear. That might be a bit tricky because I only have 250K audio taper pots. That's just gonna mean the curve as you turn it, or the response as you turn it's gonna be a bit different, which isn't a deal breaker in a volume or a gain position. It just means this thing is going to increase volume and gain slower. I'm gonna have to turn it up a bit higher, but ultimately at the end of the day, I'm gonna get the similar results. Treble, 250K L. This has a 250K treble pot, and I do believe it's a linear taper. It's the only linear taper 250 we have. 100K audio pot. Oh, that was easy. I got one of those. This came out of a Seymour Duncan Livewire heavy metal kit back in the day. Now the tricky one is this dual bass pot. 1 meg audio taper. Indeed, I have a 1 meg dual pot here. Purchased a very long time ago when I first started doing amp builds and amp clones because I saw a few schematics that used these dual pots. The Jubilee was one of them, but I've never actually used one till now. Not really. Now, this is where things are gonna get funky because whereas your taper is less important on your volume and gain knobs, it's very important for your EQing knobs. Here we have a chart expressing these particular tapers. I'm gonna go ahead and draw something resembling a grid on here. So the linear taper pot, if we turn it to 50%, what's gonna happen is it's virtually going to equate to the audio taper being turned to about 8. So if we actually want to set our bass to half, well, we have to turn our linear taper down to about 1 or 2. So basically our response on the knob as we're turning is going to be far out there compared to what's normal. Most of our range is going to be between the 9 o'clock and 12 o'clock position. By the time we hit 50% 12 o'clock, we're pretty much maxing out the bass. So it's going to work, but expect to have the bass knob at like 2 or 3 all the time. You know what I mean? Now, is there anything else specialty or different going on here? Or can I start the build now? Oh, yes, I think I can start the build now. Oh, iron's all hot and ready to go. Got freshly primed that tep bod. Where do I even start here? I'm gonna have to start with the, I think, power supply. Fresh cans. Oh, we really gotta dig in and around here a bit. This Moret's kind of in the way. We should be able to work. I have this main ground wire coming from here. That's gonna go on to there. And then I have this ground crossbar that's gonna link these puppers together. All right, we're about to make our first solder connection, establishing a ground point for the power supply. It's not particularly important if this thing touches the metal because it's all ground. I'm gonna have to keep running for parts as I need them. Now we need to bridge these two connections together because if I recall correctly, according to the schematic, the 250s are paralleled out to make a single 100. Well, we have to make sure we connect our power lines. This one of which looks like it needs to be recut because it's gotten a bit worn out. These old vintage wires that came with the Traynor, they're really handy, but they're starting to see a lot of wear. We have established here a main power bus. Just need to get that onto the cap, and that should do nicely. Our B plus is now filtered, bud. And then on the other side, we need to go out to the choke. Need to be quick with the fingers to reshape pinch wires together. Needless to say, you're used to getting burned when you do this a lot and end up with these tough fingers that are less susceptible to heat. Now, one change I made was in the standby circuit. Traditionally, Traynors had this arrangement, or at least the nice ones, where as you flick the standby switch, it would rotate between these two lights. The red would be on while it was in standby, then it would switch over to the green when you go live. I have disabled that feature. I have just hardwired the heaters to the green light. So the green light's just gonna be your standard power switch. You turn on the amp, you're gonna get the green light. The red light is gonna be rewired to be my channel indicator light, like that little red LED that tells you you're on the boost channel. So I'm going to be using a more standard switch for the standby. I'm using the same standby Traynor has where it just grounds out the circuit. The Marshall way of doing things is a bit safer because it means there's no B plus flowing through your circuit that if you come in between it and ground you get electrocuted. If you're working on a hot amp, that's handy. At Traynor, all the circuits still have power going to them. It's just the ground gets turned off. So you have to be more careful. I'm used to working on it like that, so it's going to be fine. But one of the reasons why I did it is it allows me to repurpose the DP-DT switch that it comes with and mount it back here, and that is going to be our pentode triode switch, which because of previous mods I've done, I've already got labeled. The reason why I'm bringing that up now is because the next thing we're hooking up is the screen grid, and that means I have to hook it up to this switch. And conveniently, the switch has this crossbar wire here, and the wire that normally goes to the screen grid resistors has to get removed. I don't think I even need one this long for this application. Switch is gonna go in right here. Oh, she sticks out, bud. This little piece of wire here is the perfect length. So let us get it installed onto the switch. Now we're not gonna screw that switch down yet. We might need to rotate it a bit, but where's our choke wire? It's hiding. It's hiding. No, seriously, where's our choke wire? Somewhere around here is a black wire. Oh. I kind of messed up. The choke's already connected here. This is the return wire for the choke. That's what I should be hooking up to over here. Okay. It's okay. We all know I love doing things twice, right? Now let's hook the switch up now that we have proper filter facilities. Except not solder it down yet because we need to jumper these two guys over. This is where it's gonna get a little bit tricky because I wanna do this in such a way that I can change the value easily without having to manipulate on the capacitor itself. So I got a couple empty holes here that I'm gonna set up to mount the dropping resistor. So I have this piece of wire coming in here. Now let's solder that all to place. Boom. All right, now let's get our dropping resistor. All right, there it is. It's got quite the hover going on it, but you know, it'll be easy to change if we have to manipulate the value, change the voltages going into the preamp. Further expanding on the fun times, that is the screen grid, we need to disconnect these resistors. What are these? These are 1.5Ks. That was my other way of doing things. 1.5K, 5%, not necessarily the correct value. 1K is the correct value. 1K 5 watt even. These are 3 watts. Well, I know they work, so I'm gonna keep them for now. I've been running 1.5K instead of 1K screen grid resistors in my amplifiers for a very long time now, and I don't know that it's had any real detriment to the tone. I might want to look into that. Now, the screen grids, we need them to come around now, and instead of going over there, come over to the center point of the switch. A little bit of point-to-point action here, because we now have a situation where we have to jump pin 3 over to the top of the switch. So we need to open up one of the holes. Need to get a piece of wire in there, fuse that pupper up, and then it's going to connect to the top of the switch position that's servicing that tube. So what happens is when we flick the switch up, it takes power from the screen grid power supply and feeds that to the screen grid resistors. When we flick the switch down, it taps power off the anode of the tube and routes that to the screen grid resistors. And that's our pentode triode mode. And theoretically, triode mode is less power output. And that's how they get the 2550 mode or the 5100 mode. I just do the same thing on the other side. One of the reasons why I went with 1.5K screen grid resistors is because I couldn't find a supply of 1K at the time. This was a very long time ago. 1K is common, 1.5K wasn't as useful. So I found wax of 1.5Ks, but not very many 1Ks. And with this little solder joint, we have completed this aspect of the circuit. Ta-di-da, we now have pentode triode mode. We can tighten up that potentiometer and call it good. While I'm thinking about it, I should reconnect this new standby switch, the angle of which is going to be harder for you to see. Well, that's done. It's just hooking up a switch, 2 connections. Nothing fancy, you didn't miss anything. What's next? Ooh, preamp or the phase inverter. This guy right here. So this guy, this wire is too short now. How did I plan this layout? See, now is when I have to refer to the map to figure out what I was thinking. And yes, indeed, the wire is going to go straight from the cap to the phase inverter. I'm going to need a longer wire than this. And also, I'm going to have one of my 10K dropping resistors hanging out in this general area. So I need to empty this hole. That hole, which is full. I don't know if I'm going to be able to fit a wire and another big power resistor in there. We'll lift these components out so we can clean this hole out real well. Oh, you got to keep fishing for your tools, bud. All right, so we have to get one of these large 10K droppers into play. Oh, geez, yeah, that's not going to fit the best, is it? That is a busy hole. Or maybe there's just enough room. Generally, I find you can fit 4 connections into these methods of hole. All right, where'd our big resistor go? Right here. Okay, we just fit all these guys in there. Whether or not we want a big dropping resistor in the middle of a phase inverter is up for philosophical debate. One of the reasons why I said the layout of this isn't exactly 100%. But I do believe we're done connecting things to this pole of this transformer, so let's solder it up. And this ground lug, what are we doing with this ground lug? Traditionally, I like to have a bleed resistor. It's a resistor that, you know, it's 100K to ground. It allows the power to escape when you turn the amp off. I was using this 120 before. Marshall doesn't call for one of these. Looking at the schematic, there's none here where it often might be. There's none here. In my initial schematic for this amp, the way I ran the preamp before, it was connected to the other side of the choke, the screen grid supply. That'd be right here, which is now pretty busy. We'll see about it later, because this might affect our voltages. You just gotta be careful when you're tweaking on this thing, because those capacitors are gonna stay hot for a little while. Either way, I'm gonna finalize the ground lug on this guy, and our main cans are done. Now next up, I have to make some changes in this general region here. So I wanna put fresh capacitors here, because if you're having trouble with bias stability, sometimes it can be related to the capacitors. Oh boy, this is virgin solder down in here. The leads on these are just a touch too short. This is a tight reach, but they'll go. Next up, we manipulate in here. So in the Marshall schematic, it has 22 or 0.022 coupling capacitors here. This amp has 0.1s. It has two 20K distribution resistors for the bias. This one has 100Ks, so we have to change those out. And then the grid stoppers for the power tubes are 5.6K. This one has 2.7K. Basically, that's in and along the line with how the original phase inverter for this amp was, which pretty much works. And I'm pretty sure I could probably just leave all that there like that, and it probably wouldn't make a difference, but, you know, I guess I am pretty much rebuilding the phase inverter, aren't I? Pump. There's some nice 2.2s. And we need a 470p, or no, sorry, a 47p goes across here. Apparently it's supposed to stabilize the highs. I got her sticking out quite a bit. Hopefully that's not a problem. These are the 5.6Ks that I have to work with. They're nice 1% metal film resistors, which, you know, I like the 1% to the 2% when they have to be balanced circuits. And you know, there's voodoo that's discussed the difference between carbon and metal film and stuff. They're gonna be quieter resistors, less hiss. That's good here, but less toneful. They say they sound sterile, but you know, for this application here, I'm good. And you'll notice sometimes I leave my leads exaggeratingly long. That's because when I know something's a clone like this, and I might do something different with this chassis later, I like maintaining my lead options. Now we get these 220K distribution resistors into place. Again, I opt for a high tolerance metal film. There we go. Our phase inverter is pretty much up to date now, with the exception of this 10K, which is an 8.2. That I'm just gonna leave that one. Actually, there is something else here that needs to change. This guy right here. That's the feedback resistor. It's a 47K. The Marshall uses 100K off the 4 ohm tap. So let's pull that guy out. And let's get a nice 100 in place. And currently the wire is tacked onto the 16 ohm tap. We need to move it down to what I believe to be the 4 ohm tap. Ta-da! I think it's starting to I think it's time to start working on the preamp. That's partially fun. You just kind of hammer a bunch of components down, as per what the map says. But before I can do that, I should probably get all my pots into place. The treble's already in place, and then the 1 meg, the first 1 meg. The base, this is you know, got an awkwardly long shaft. Is that what she said? We're gonna have to trim that off later. Whoa, it's gonna be hard to get at those contacts. Might wanna leave these loose just in case we gotta kind of finagle them out. Where's this next 1 meg go? Oh, the master. And lead output goes right here. My 250 here, or my 100, I need to go find hardware for it. So we're gonna go ahead, we're gonna start working on up here. We're gonna get these connected and bridged, because if you look at the schematic, there's a lot of connections in the EQ circuit that are jimping from pot to pot, and the layout does this similarly. I've gone ahead and pre-prepped most of these pots to get them ready to solder, and I've added this terminal strip right here because no amount of lead length on a component is going to reach all the way from the base to the treble. And well, since that's what I was working on, we're going to go ahead and get this 100K in place. I think this is going to be easier if I take it out though. These two terminals get bridged together. Or actually, you know what? We already have this guy grounded out. It's going to be harder to ground this guy out. So I'm going to do this connection on the rear. It's not really going to make a difference which we do it to. So just kind of jam this in a hole there so it would stay put. Then reinforce this ground connection. The grounding scheme in this amp's being done a little bit differently too. If you look at the arrangement, they have a unibus design here where pretty much all the grounds connect to one bus, and it's a little bit confusing because you're kind of not supposed to do it that way in some senses, but these old chassis, they're hot chassis. They used a different way of grounding, and mostly because all the components are hard mounted like the input jacks, I'm going with a more old school grounding method. For instance, the entirety of the preamp circuit is grounded to the input jack, and the input jack is hard mounted to the chassis. Basically, your chassis becomes one big ground bus. That's what's known as a hot chassis, and it's the kind of thing that if you do it wrong is dangerous. You can get electrocuted. And the only reason why they got away with it back in these days is because they don't build it like they used to. You know, everything in an old amp like this is heavy duty, hardcore, hand wired. There was less margin of error. You could drop these things off a freaking house and they wouldn't lose connections. It's not like amps today that have delicate PCBs where just the expansion and contraction of the heat cycles would cause connections to loosen up and possibly create a failure mode where you could get electrocuted by touching the chassis. Now that is one of the things that I've had a lot of experience with my clone, and one of the reasons why my dual rectifier clone didn't work properly at first is trying to work that grounding scheme into these old school style amps. And I've figured out how to do it now, so this amp should function relatively quietly. If you ground things wrong, stuff gets noisy, and when stuff gets noisy, high gain circuits get unstable. All right, now we need a wire that's gonna go from this point on the treble. Oh look, we already have this wire here ready to go. It's too short to do the other thing that it was gonna do. Actually, we can use that as a point for other connections, so let's not solder it up yet. Oh, I should put that wire over top of this blue one though. Yeah, like the pots, this wire's already soldered on there nice, and pots are sensitive to heat, so when we look at the schematic, we got this 22U here jumping over to the middle. That's perfect, because the mid's right there. We can just jump those connections. And then we also have a wire that's going to return to the preamp, to this 10K here. Or no, it's a 0022. That's the component I special ordered, 2.2 NF. This terminal strip was a good idea. Oh, it's time to bust out our wire kit. Let's get her on there. Fuels all the joints. Oh yeah, we'll be sounding like Slash in no time, right? Oh, it's like this wire was already being used for this purpose. You think? What else do we got going on here? A 470p bridging these two positions. Oh, will our 470p reach, bud? Got this dinky little thing here, and yeah, it will. It definitely will. This capacitor's so flimsy, you're worried that it might not last. And in fact, I've had the leads break off these guys. Okay, what's next? I need a 100K from there to there. I think I have a dinky little one kicking around here. More with these little blue resistors. I'm sure the tone purists out there are loving them. Ugh. You have to be too tight of a hole, eh, bud? Pull that down a little bit nicer. Okay, that'll do. And wires will come off there. Going to the preamp circuit, middle to the preamp circuit. We might as well connect that master volume where we bind the phase inverter to the master volume output. Right here. Concentrate up here. There. Our pots are prepped. We're gonna start putting stuff on this board here. We need a 0.1U and a 1U. Oh, we got a nice semi-appropriate 1U right here. For 0.1s, they just have these little NTE dealies on a 100K. At this point, you can't really follow the schematic. You just have to trust that the map you drew is correct. I don't have a whole heck of a lot of options for 10K resistors. I just have these carbon comps, so they're gonna have to do. This amp's gonna have so much character, bud. So much character. And we've ascertained that this wire here goes to that. The other half of the 10K goes here. We are making progress. This is now starting to go underway. And a lot of this is probably going to get cut out.